Next topic is multiplication and division, come on, of complex numbers. So I'm going to go through a mini proof. We would do it in class, but I have it all here for us. All right, so if z sub 1 equals r sub 1, basically cis of theta sub 1, and z sub 2 equals r sub 2 cis theta sub 2. So basically you have two different complex numbers with two different r's and thetas. And this is a proof just to show where the equation comes from when I'm multiplying them. So if we were to multiply, you're like, on what planet would I ever want to do this? But z sub 1 times z sub 2. So here you are. Here's your z sub 1. Here's your z sub 2 by the definition above. R sub 1 times R sub 2. I'm going to put that out front. And then I just kind of saved a little bit of work here. So basically I'm going to have to write, I have a binomial and a binomial. I'm going to have to FOIL them. So cosine of theta sub 1, cosine theta sub 2, that would go right here. Now the other term, that's not going to have an I attached to it, just for sake of saving myself from writing a lot. When I'm foiling this out is when you do your last terms together, because you would have I sine theta sub 1, I sine of theta sub 2. So when I multiply those i's together, I get I squared, which gives me the negative 1 here. So that's the theta sub 1, theta sub 2 comes from. So again, I just group those together. And then back here, I will group together the I terms while I'm foiling. So that's going to be your outer and your inner. So cosine theta sub 1, I sine theta sub 2, which for whatever reason I wrote over here. And then your other one, I sine theta sub 1, cosine theta sub 2, right here. Both of those have an I, so I just factored that out. So if you looked at this right here, okay, that's really the definition of cosine of theta sub 1 plus theta sub 2, the sum of two angles when I'm taking the cosine of it. And then over here, this is really the definition of I sine theta sub 1, theta sub theta sub 2. That's from last unit where we looked at those equations. Okay, and so that is the equation that we will use when we are multiplying two complex numbers together. The division proof is basically the same, but I wasn't going to bore you with that. Maybe you already fast forward through me talking about the proof. But for division, this is what you need to know right here. R sub 1 divided by R sub 2, and then you're just subtracting the two thetas instead of adding them. All right, so let's get to an example of each. I'm trying to make this as painless as possible. So number 4, if z sub 1, is defined as 8 times the quantity of cosine of 120 degrees plus I sine of 120 degrees, and z sub 2 is 6 cosine, cis of 150 degrees. Fine, so part A, z sub 1 times z sub 2. All right, so I can just use my awesome equation. So R sub 1 times R sub 2. So I'm doing 8 times 6, so I'm going to get 48. Okay, and then it says I have to add them together. So that's going to be the cosine, my two angles, 120 and 150. That's going to be 270. It's going to be the same for both. Plus I sine of the same number, 270. Okay, so now I just need to simplify. So I need to know that the cosine of 270 is going to be 0. And the sine of 270 is negative 1. So really this is a negative I here. So my final answer is negative 48I. And I'm done. Okay, if I asked you to divide them, z sub 1 divided by z sub 2. So I take my 8 divided by 6. Come on and focus. But we know 8 divided by 6 is 4/3. So we'll save ourselves some simplifying there. So 4/3. And then I have to, based off of this division one, we're subtracting them, theta sub 1 minus theta sub 2. So 120 minus 150, that's going to be cosine of negative 30 degrees, plus I sine of the same thing, negative 30 degrees. Okay, so I didn't leave myself much room. What else is new? All right, so I need to know what the cosine of negative 30 degrees, that's going to be a positive root 3 over 2. And then the sine of negative 30 degrees, that's going to be a negative 1/2, and then I have the I attached. So now just some simple algebra there, distribute in. That's going to simplify to 2 root 3 over 3 minus 2/3 I. And notice those are written in standard form, both of those there.